Okay, let's get started. I understand we left off on slide number 28 on this particular lecture last time. So let's see if this works. Slide number 28. So actually now I'm getting so used to this Neo Office. I like it better than the Microsoft Office. Because the Microsoft Office you have to start from the beginning and go to the slide number. Here you just pick the slide. It starts from there. So it's actually kind of nice. All right, so what were we talking about last time? Just to refresh your memory, we were finishing up with some of the features that are associated with the Java EE, some of the things that we covered in terms of the terminology, but not the programming aspect. You don't actually have to use JNI, and you don't have to use any of the transaction supports or anything like that in any of your assignments. However, it's not a bad idea to be familiar with the technologies, and so I was giving you an overview on the technologies. And here's actually probably a good kind of review to pick up where we left off last time with the Java naming and directory interface, so GNDI. So from an application perspective, we make an instance of an object to support JNDI, and so that instance of the object communicates with the application. And then it communicates with what's called a naming manager, which is part of the platform that gets loaded. It's sort of very similar to RMI, think about it. But the manager is the register in the naming lookup convention. Why do we want to do this, and why do we want to use this technology? It supports the distributed object concept. So if we have everything on one computer, we don't need a naming lookup service. In fact, if the entire internet was on one computer, we wouldn't need domain name service either. So, but this is sort of similar in concept to a domain name service. It looks up locations to where to find objects. So you give it a common name, you use the same name, you move objects around all over the place. Doesn't matter where they are, as long as you update the name registry. And then what ends up happening is it'll find it wherever it happens to be located. So it gives you a little bit more transparency with the running of the application and the physical locations where everything is. It doesn't really matter where anything is. It sees right through it and finds it wherever it happens to be located, which is why the JNDI has become sort of a useful thing. Don't really need, and we'll never see this unless you implement distributed applications, especially using multiple different resources. And here we have RMI on the bottom and CORBA, which I'm going to talk about today. I have a brief little lecture on CORBA, just to introduce the concept to you. NDS, NIS, DNS, we should be very familiar with that, LDAP. So these are all, we call them services slash protocols slash middlewares. A lot of these technologies fall into multiple different categories, and JNDI is basically a blanket for the entire interface to those technologies, which is why you've got this little box going on here. So, okay, enterprise Java beans. Talked about them last time in terms of the different types of enterprise Java beans. We have entity beans, session beans. These are bean technologies. You know, for purposes that they are intended to serve. So Java beans are written in Java programming language. It's an enterprise bean is a server-side component that encapsulates the business logic of the application. And the business logic is the code that fulfills the purpose of the application. That's the definition from Sun of about 2006 when beans were actually invented, which doesn't seem like it was that long ago. But now that I look at the current year, I go, well, yeah, it's about 6 years ago, so I guess it was a long time ago. So hard to imagine how time flies. So as an example here for a university student, services, applications, the logic would be the registration of the students, but not the underlying networking code, allowing the registration via a web browser. So it's the logic that's encapsulated into the bean. So enterprise bean typically contains business logic, operates on enterprise data, persistence data, and then we have enterprise beans instances that are created and managed by the runtime at a container level. Remember I talked about containers last time. In terms of housing beans, putting them in a jar, well, not really a jar, but that's really the concept actually. You put a bunch of files in a jar and you seal it up and it gets a .jar extension. But the container is actually a similar concept, but you put the beans in the jar and then or beans in the container, I should say. And the container is a kind of a package. It's all sealed together, kind of, in terms of the abstraction. Enterprise beans can be customized at deployment time, editing its environment entities, entries. We have various different service information that's associated with them, such as transaction, security, separate enterprise bean classes that can be configured without changing any of the software. So if you configure the beans, you put them into containers, and you distribute them along with your application, you end up, and here's just refresh your memory here, this is the web container, here's the enterprise Java bean container with our enterprise beans that are located inside of them. It makes it a little bit easier to understand in terms of the overall abstraction of the concept. There was, here it is, this is the slide I'm looking for. These were the 3 different types of beans that I went over last time as well, just to refresh your memory, the session, the entity, and the message-driven bean, which work, they're all done the same way. It's all Java programs. But they serve different logic purposes, which is why they get the different names associated with them. Gives us ability to kind of put a different label on them, in essence. So here's the big picture, the basic enterprise Java bean architecture. So this is another picture, not as colorful as the other one I was showing you a few minutes ago. But this one actually is just showing you the enterprise Java bean container, which is what this says up here if it's kind of far from you. We have the home object, we have the enterprise Java bean objects. Let's say, for example, and these objects would go with a home interface or a remote interface. And the interface would be invoking stuff from the client level. So here's the client, here's the server. This whole thing is the server. And on the server, we have the container that has the beans. We have the enterprise Java bean itself. These are just small little pieces of programs that are connecting to resources. And in this particular slide, we're looking at one resource. We could stick a bunch of resources out here and have a bunch of different beans all connected to it with the same architecture. We do this because the interface from the client is through the bean. Actually, it may not even be through the bean. It might be through another service. But from the resources perspective, it's only communicating with the bean. So you can limit exposure to the client. You're not putting this out there, making it vulnerable to the internet. You're not creating a situation in which it can be misused or broken into or anything. It's hidden, generally on a back-end server. So not usually on this server. If you're going to put it on this server, why bother? If you think about it, because you're already exposing yourself. You can put this on. If you put everything on a web server, you might as well just forget about security to begin with, because you're just opening it up to problems. So if you tier it properly, then you can put layers in and then shield the protective stuff, put it towards the back end, which is why they usually call it the back end. It's like the back line instead of the front line of the fence. Here's the enterprise services and APIs. This says security on it, messaging, transaction management services, INDI, just talked about a few minutes ago. These are just blanket service modules that are working in the configuration. So you can kind of see this is very similar to the other pictures I've been showing you, but this is just broken out showing you beans. And we have no such thing as an enterprise Java bean client, although we could. It could be we could write a bean component. I'm not going to call it a bean in that particular case. I'm probably going to call it a Java program. And it's going to run on the Java, not necessarily an applet. You could write actually a non-internet application, just a program, run it out here on the client machine, and it could run and connect to the server just like a regular old web application, actually. And most applications run this way. Most of your update services run this way. So it's the application that's going out and saying, hey, is there an update available? And it comes back and it feeds the information to the application and says, yeah, download it. Here you go. It downloads it. So kind of like the way Firefox and a lot of your web browsers and a lot of your programs do updates these days. So the Enterprise Java Bean server provides the organizational framework for the execution environment in which the containers can run. Makes available system services for multiprocessing, load balancing, device access. Also makes it for running within visible, for the Enterprise Bean container, running within them, visible to the outside world, but closed off in terms of security, or in terms of exposure. So the bean container makes the services available. And provides vendor-specific support for features to optimize data storage interfaces, such as CORBA services, which is what I'm going to talk about next today, SSL support, INDI support, all sorts of different things. So in here, the configuration had two objects, and it had a home object, and it had a enterprise Java Bean object. I'll talk a few more things about those two types of objects. The home interface and the home object contains the factory methods for locating and creating, removing instances of the Java beans themselves. The developer defines the home interface for his particular bean. It's just a category of bean, call it that. It's generated by tools provided by the container vendor, and the home object is implementation of the home interface versus the remote interface. And you're wondering, well, what's the difference between this home object and remote? Well, it depends on the locality of what services it's providing. Remote object or remote interfaces, and this is kind of deceiving because they're both going out to a client. So this client is definitely, this is invoking business methods for definite client server from off-site clients who are accessing it. This here, it's also removing instances, creating instances, managing the home environment in terms of which objects are available and which instances are currently executed. So these guys work together. This guy services up the clients. This guy services up the objects that are needed for these clients. So they're sort of working in unison. And it's just that you can build the logic all into one if you wanted to. But for better abstraction purposes, it looks better, cleaner to separate it out. So the remote interface and the object itself, remote enterprise bean object, lists the business methods present in the class. Remote interface also is defined by the developer. Both of these are defined by the developer. Concentrates on the class for remote interface. It's generated by the tools, by the vendors itself. And again, it uses methods to present the interface, to invoke business methods. So both of these two slides are pretty much saying the same thing about the objects, but just think remote interface is actually providing, a remote object is actually providing the connectivity, and home is making the instances of those objects and managing the object life cycles that exist, that are being serviced up by the remote objects. Okay, the containers. So the containers themselves act as the interface between the enterprise beans and the lower level platform specific functionality that is run on the beans. So it's the interface. So usually if you go back to RMI, because most people at this point in the course have figured that out hopefully, if not, you got some catching up to do. In RMI we have an interface, and that interface provides the, this method's available, that method's available. And which is the same thing the container is doing. It's the interface to the Java beans, but rather than creating a separate interface for every single bean that's out there, we house it all, stick it in a container, and create the container interface. And container interface is, okay, inside of my container I have this object, that object, that object, and you're allowed to use this one, this one, this one, and that one. And it services up the objects that it can hold, and it provides the interface to the objects. Because you can't just go in to one of those objects, just like in RMI, you just can't go and connect to a remote object. I mean, it'd be nice if you could, but where is the security in that? So you have the interface that defines the legal rules that you can use, which is a separate class module actually. It's a separate file here. This is also a separate class module that gets implemented that essentially does the same thing in theory. So the container vendor is also free to provide additional services as well. Implemented at either the container or the server level. This is where CORBA comes into place as a kind of a crossover technology that can also be used for the interface definitions for some of these container functionalities. The client never accesses the bean directly. It goes through the container first, and the container or the interface. Just the same way in RMI, you never actually access the remote method directly, you go through the interface. So, sort of the gatekeeper. So any bean access is done through the methods of the container-generated classes, which in turn invoke the beans methods. So just think of the container abstractly. It's holding all the Java beans, but really, what is it? It's a class. It's another object that you're. All of these things are objects. So it's another class that you're creating that turns into an instance of an object that acts as the interface. In theory. So having the container interpose on all of the bean invocations allows the container to manage transactions as well. Load the bean instances if necessary, and in general do all of the wonderful things that Enterprise Java beans do. It is another bean if you think about it, but it can actually be used to manage the transaction management as well, just the same way as the register is doing transaction management in theory, but not keeping track of it usually. You could build that logic into it, because if you're going through a register and it's serving up interfaces to objects, then why not put it right there? So all of these technologies should hopefully be working together and complementing each other in terms of getting not only security but transaction management and other components accomplished. Two types of containers exist. We have session and entities. So just the same way as we have session beans and entity beans, session containers that may contain transient, non-persistent enterprise beans whose states are not saved. Well, yeah, each session would load up. It's almost like cache memory, or it's almost like, session bean access, and then when the session's gone, it goes away. It doesn't stay around for very long. Or entity, which can contain persistent instead of non-persistent enterprise Java beans whose states are saved between invocations, because it's for the entity and not necessarily for the session or for the user. Think of it sort of like client sessions if you want to, or not really. It could be a client could have multiple sessions going on, though. It's not one-to-one in terms of the relationship. So the enterprise bean itself, the real enterprise bean itself, is contained inside of the enterprise Java bean container and is never directly accessed by anyone but the container. So as we walk away with that, you'll get the concept down, at least in theory. So the containers mediate all of the Java enterprise beans, does not implement the remote interface within the bean itself, it uses skeletons. It does not actually implement any of the bean functionality, and it does not actually implement the remote interface. So it's that's where it kind of differs a bit in terms of usage if you were comparing it with other technologies. Skeleton can sort of be like an interface object if you think of it, though. Because what is, if you think of the concept, I mean, what is a interface for RMI? It's sort of a skeleton, it's a template kind of thing. I don't like to use the word template. I don't actually like the word skeleton either, but it's an interface. So skeleton interface, it's kind of the same kind of concept. It's providing, it doesn't do any of the implementation, it just says you can run that, you can run that, you can run that. It's kind of like taking the protective mechanisms of public, pulling it out, making a list of all your public stuff. So here's the big picture again, where we have the enterprise home, the entity remote out here, the entity bean here, the session bean here, and we're just separating them out now into two separate containers. One container up here says, it's hard to read this, but it says entity Java bean container. Down here on the bottom it says session enterprise Java bean container, where we're looking at the session related one. So it's just another way of abstracting it out into two separate containers, keeps it organized. And so we have the client over here, we have multiple clients over here, any number of clients, and then we have the lonely database back here by itself, waiting to be connected to, and it only gets connected to by this abstraction here. It doesn't get connected to by the clients. That's basically for efficiency as well as security and transaction management. You can name off a lot of other different characteristics. Well, we're not going to actually discuss many more of these beans, so this heading on the top here is kind of deceiving. And I'm not going to go through all of the huge list here, but just to summarize this for you, and the differences between the session bean and the entity bean. The data members of the session bean contain conversational state. The data members of the entity bean represent actual data in the domain knowledge. It's not really state related. So the data itself differs. Entity beans share database access for multiple clients, and session beans may handle database access for a single client instead of the multiples. So entity is more on the lines of the object entity managing that. Sessions are managing clients, so you can sort of think of it that way. Probably get a better explanation of it. Let's see. Sharing or storing per client state information, and this is not allowing per client information between the session and the one-to-one. This is also a one-to-one, but it's with domain knowledge, or domain model, excuse me, and not with the client. This one is a one-to-one relationship with the client. So sessions in any concept in terms of web development, the session always deals with the client, and entity always deals with the server in terms of the functionality that it's taken care of. Entity beans are transactional. Session beans can be transactional aware, but they're not good for long-term transactions because once the client goes away, so does the session. So it just depends on how long the session is going to stay. And session beans do not survive server crashes. Nope. But entity beans survive server crashes. So sessions go away. Actually, they don't survive missing clients either. So let's talk about the Java, Enterprise Java Bean client. Finds the container using the JNDI. So the client bean interface is using the lookup service to find the object that it needs to run the service for, which is why I kind of summarized the JNDI thing at the beginning, so you can kind of see the big picture, I hope. It's a lookup service. So it uses the bean itself, contains containers to invoke bean methods. Client only gets a reference to the object instance, not the actual bean. Gets a reference to the bean. Well, what does that mean? It's the same thing if you think about it. It can't change the bean. The bean is not mutable. Uses home objects to locate, create, or destroy the Enterprise Java Bean class. Because the home objects, client object is working with the client. Home object is working with the. If you go back to this slide here. These guys, I'm talking about this one right now. These guys here work together. So this client bean interface, which is interfacing with the client, is working with the home object. Home object never really interfaces with the client. Instead, the home object goes this way. So you could and this is kind of deceiving. I probably should edit this and take this part out a little bit because it's adding and removing instances for the client. But it's really getting its information. It can get it from the client, but it's really supposed to be getting it from the client object instead of the client. But you could send it past. You could send it past into the server this way as well from the home interface. But it should. This thing, which should look like this. Oops. You know, if I could draw a line here, I'd go from client to this way, up to here, to this way. Because this guy is not usually communicating with the beans either. So this is kind of a weak connection, and this is sort of a weak connection. And the connection really is here in terms of the functionality, which is what the slide is telling you in these first couple of lines here. So the client only gets the interface, uses the home object to locate, create, or destroy Enterprise Java Bean and classes, instances of classes, uses the object instances to invoke business methods, and on the Java Bean instance itself that it's using. And just for terminology's sake, although the slide set says classes all over the place, classes don't run in real time. Classes are what programmers create. You substitute the word class with an object for everything that is running and everything that's being executed and accessed. Technically, yes, the home object is working with the client object class and vice versa, but it's really instances of objects that it's manipulating and working with. Take a look at the life cycle and the roles of the Java Enterprise Beans. So Enterprise Java Beans server provider creates the servers, the container providers create the containers and the tools, the developer creates the beans, the deployer deploys on the server, which is part of your server functionality. Your application assembler, also part of your server functionality, uses the beans. So it's many different ways of configuring the systems, many different types of servers and connections that can actually exist as well. Way too much, way beyond the scope of this course. So this is more of a networking technologies type of subject matter. But here's the big picture. Here where we've got the server provider providing the service, which the container provider is using. This might be an abstract concept. All of this stuff might be on the same computer. So don't think of this as hardware specific. Think of these as abstract components. This bean here, we have the developer who's creating the beans, or and then the beans themselves that are deployed or deployable from applications in terms of creating instances and running those. And yet another one. This is the same components here in this bulleted list and sort of loosely diagrammed out here in a different type of, it's the same pieces, different type of diagram, looking at the components and housing them together where they belong. So here's our remote interface, here's our home interface. This is the same thing we looked at a few minutes ago. That's the one I kept going back to and showing you. I kept going like this with it. It's that the lines are here, and we've got the connections, and this is the client out here, the JNDI. So if we put in here, the client's interface is always through JNDI. JNDI is going to resolve the locations for all of the home interface and the remote interface objects. It probably is going to go through the remote interface first. It could go through the home interface, however, but it doesn't have to. You could design everything to go through the and then we have this connection here where home is going to talk to the remote object and vice versa. And this arrow here goes back up here. So this object here is communicating. We could put another arrow if we wanted to, make that a two-sided arrow. It depends on how we configure it. And then the skill is actually in figuring out how you want to configure it, breaking it out. In the objects themselves, both of them are going to go into bean instances. This is a container holding bean instances of objects that are created, and then we have the maybe some bean context to consider, like this bean is good for that database over there, that bean is good for that database over there, or different types of databases or different types of services or stuff. This is a really terrible diagram, actually. So if this diagram makes absolutely no sense to you, you're right on par. There's nothing wrong with you. It's the diagram. So. Because this diagram here is really, it's really this one. But with more connections, or actually the one I showed you earlier, I won't go back to it, but it's definitely more confusing. I think it's because of the way it's drawn. It's showing you the methods. Here, we have a client creates or finds, and then we have, kind of call a bean method. And there's numbering in here, it goes from 1 to 2. So look up books, find, create, do a create instance or find the book here, and then 3 comes out to the deployment descriptor, and then 4 goes back down here to the remote object because it has to give the information that it finds back into here anyway. And then 5 takes us back, but you're wondering, how did you get from 4 here back up to here? So the arrow should be double-ended actually. Then 5 comes out, or actually, I'm sorry, it's right here. So 5 comes out here, back up to the descriptor. So you can, basically it's a path of logic. You could rearrange the path of logic. Big picture, these guys are communicating. These guys are communicating. And they're communicating back and forth, and then they're going back to the client. So how the client gets in, how the beans are working, in what order, it's up to your design. So. In developing Enterprise Java Beans, you define your home object. You define your remote interface, your home interface and your home remote interface, and those objects, corresponding objects that go with them. You develop your entity and your session beans. In this case, entity beans defines the primary key class. Sort of like a database, actually. Write your deployment descriptors. Compile your classes and generate the container code using the tools provided, depending upon which toolkit you're actually working with. Set up the data source for the database, develop your client code, start your server, execute your client, and there you go. See, that's how easy it is. So, a little bit more complicated. There's a little design. There's some pre-planning and diagramming to actually get your design to work correctly. So the contents of the Enterprise Bean, to develop Enterprise Bean, you might have to provide the following files. So these are all the components that come together. In a lecture, I believe, the beginning of this particular lecture, I showed you something similar to this picture here. This picture here is a graphical version of this slide here, letting you know that the deployment descriptor obviously is an XML file. Everything's XML, and in terms of descriptors. So it specifies the information that's inside of the persistent type of the transaction attributes. Here's our XML files over here. that are describing the descriptors themselves. The enterprise class itself is written in Java, implements methods for the interfaces. So we have the interface method, we have the local access for local home interfaces that are required, and we also have the access for web services and other things that might play a part in there. And then we have helper classes. How do you know you need helper classes? Well, it's kind of like how do you know when you're making a Java program, how do you know how to divide your classes out? You're going to use some design pattern that's associated with object orientation, and here it's going to be associated with bean orientation and container logic. So other classes are needed for enterprise bean classes, such as exception handling, utility classes, and stuff like that. So our assembly root has all of our class file modules in it, has our meta information that's going to keep track of and kind of encapsulate the mappings, the configurations, the definitions, excuse me, the descriptors, their interfaces, all the different pieces that are going to go in there. So, and here's some naming conventions for enterprise beans, and these are just conventions. The DD means that the item is an element in the beans deployment descriptor. DD actually you'll see is abbreviated for deployment descriptor. In a lot of ways, that's those XML files that describe which beans are where, and XML is basically mocking it up to say that this is an entity, this is a session, this is a message bean or something, and this is what we're using it for, and because then it basically defines the bean nature or the bean existence, because you're describing what's in the container through the descriptor. So these are just, item here might be an enterprise bean name. So it's going to be bean, and that's going to be the name, and it's going to be account bean, so account jar. And this is just some common naming conventions that people use. They use the word home, remote. They use, the word bean in their jar. So the life cycle of the enterprise bean goes through various different stages. Each type of bean, session, entity, or message driven has a different life cycle. And here's an example of an entity bean life cycle where we've got, and going back to the concept, some beans are actually created when the server comes up and they're housed. The instances are available immediately. Some are waiting, and they're waiting because if they're not needed, why make an instance of it? And so session beans are like that. Session beans kind of sit there. Well, if we don't have a client, what do we need a session bean for? So clients show up, oh, session bean, instances get created. So the when the life cycle actually starts varies among the different beans as well as what happens throughout the bean life. Some of them die and go away, some of them stay, some of them get created right in the beginning, which is why you separate them out into categories. Because if you've got a bunch of session beans, well, they're all going to start together. And all of your entity beans might all start together. So number one is create, and then we create the Java Enterprise beans, and then we have a post-create kind of thing. So we can be ready, we can be pooled, we can be active, or we could be in a does not exist type of state in terms of what's happening for the instance life. So this is just an example of the entity bean lifecycle. And it's not really a good example because it's not really showing out anything outside of ready, pooled, and does not exist, and how it would go back and forth. But it does transition, and the thing to walk away with is that the entity beans, session beans, message room, they all have different life cycles and different characteristics associated with them, which is one of the reasons why we're separating them out, so putting them into different categories and calling them different things. So that was the end of a very long lecture. That was long. So, what do we have next? We have a short one. We have a sales pitch lecture on CORBA. So, as promised, I'm going to mention CORBA. Let's see. How do I get the menu to show up in here? This is interesting. Oh, there's the menu. Hold on a second. There we go. That's the wrong one. Wrong one. Don't want that one. I want this one. Oh, there we go. I don't know what happened to my menu before. I wasn't seeing the menu. I guess I have to click on the item, perhaps. this particular lecture is very graphic. It's a big size file. So actually, I want to do something first here too. Turn down the volume a little bit. There you go. Actually, let me put it back. We'll just deal with it. There's some sound effects on one of the slides, but they're all right. I don't want to mess up my recording as well. So if I turn my volume off, I may not actually, and it probably doesn't affect the record, but we'll just to be on the safe side. Introduction to CORBA. We've heard about it. We've read about it. It's just like RMI. It's just like everything else. It's just from another vendor. It's not written by Sun. It's written by somebody else. This is kind of a sales pitch kind of lecture, but it's really the only thing that, and we'll see about halfway through it. I'm going to probably, skip the rest of it, just go over about half of it, because at one point it turns into a sales pitch, actually. And it says, oh, CORBA can do this, and CORBA can do that, and look at this, and compare it to these other vendors, and okay, whatever. We just want to get the concept of what it is this technology is about. You don't have to program in this technology for this particular class, but nice to know is something about it, how it fits into the Enterprise Edition. It's not part of Java, so it's totally separate, but it works with Java, and it also works with other programming languages. So the mainframe applications, this is how it started out. In fact, CORBA was was around prior to the Java EE edition. So we have terminal access, we have mainframe data and applications that are running, and we have a client-server relationship that exists between different types of clients, and these are fat clients over here. Mac is fat, yeah, Unix is fat, Windows is fat. Fat meaning that they're computers. We can also take, we required, in the old days, we actually required fat clients, believe it or not, to get some of the functionality done, because part of the application was loaded on the client end. And then we have the back-end data over here. We had Oracle, DB2, MySQL, Informix, Sybase. And we have applications that exist. So we tiered it, and the multi-tiering distributed applications, this is kind of a recap for the course at the same time as well. The reason why we're looking at Enterprise Edition is so that we can tier it in terms of services. So rather than having a direct connection in this particular case, we have layers in terms of the connection. So now the Windows, the browsers, the Java clients can be thin. So tiering gives us the thin. So application servers are the middle tier services, or the business processes. In middle tiering, we have Unix, NT, AS400, we have, any type of server technology falls in this category. Then on the back end, we have the data. So we can go from fat over here. It's just describing our clients. Fat means we have hard drives and CD-ROM drives and terminals and everything. To thin, which means we have a cell phone or a tablet or something that doesn't really have a fast processor maybe. Actually, tablets have pretty fast processors these days, so do phones actually. Actually, your average phone right now, smartphone, has a faster process than the first PC came out. Kind of incredible when you think about it. Anyway, long story short, now they can be thin, and it can be Java clients, mobile clients. You go through this application server. So when this originally started, because CORBA was around first, it created the middleware tier. It created the middleware. In fact, CORBA is middleware as well. Gave us the business logic. Here's where the graphics are going to come in. I just put all these guys out here. That's the sound I was worried about. Okay. In terms of enterprise computing, we have some options. Enterprises have various different types of computing platforms. Unix, Mac, well, some of these are kind of outdated. VMS. Enterprises write applications in a variety of different programming languages. C, C++, Java, COBOL. Actually, COBOL's still out there. Nobody's writing new programs in it, but they're still supporting old ones. Smalltalk is still out there too, so is Perl. Actually, Basic, no. I don't think there's any more Basic around, but we'll see. Well, there's Visual Basic, but that's totally different than Real Basic. Enterprises need an open architecture to support heterogeneous environments. That's where CORBA came around. Hello. Oh, there we go. Object-oriented computing for the enterprise itself. Oh, there we go. So enterprise applications are being written in terms of objects, reusable components, access through enterprise networks. CORBA supports object orientation. So CORBA was really the first, and let me just give you the whole sales pitch in one or two lines here, then we'll go through the details. Before Enterprise Edition was even conceived, we had CORBA that came around and said, distributed objects, objects, distributed objects, nice. Windows, Unix, HP, put them all together, load CORBA. And CORBA created the common platform. It's kind of like the predecessor to the JVM, the Java Virtual Machine. CORBA is an operating system in itself. You load CORBA on it, and CORBA works on practically everything. It takes all these different types of networks and puts it all together and makes it the same. Makes it compatible. And you can write with C++, Java, Fortran, COBOL. I don't know, Fortran wasn't on the list. COBOL, BASIC, Smalltalk, all those different languages, they all work together too. So it was really a nice solution that revolutionized, which is why CORBA is still around. It was a nice solution, revolutionized enterprise computing and the whole concept of the tiering. So that's all you need to know out of this lecture. Let's go through the details though. CORBA supplies the architecture for the distributed applications based on open standards. CORBA is open, not owned by Microsoft, it's open standard interface. Which means, how are you gonna get heterogeneous networks and clients and everybody to all communicate together if you're gonna hide your source and you're gonna hide your implementation details? You have to open it up. It's kind of like how Java, it's open. It's open as well, because how are you gonna write third-party libraries? How are you gonna write, interfaces? How are you gonna utilize it if it's not open? So there's pros and cons of being open. Open, you can't sell it. But you can develop it, and you can grow it. So CORBA started out this way in terms of the foundation, and it quickly grew, quickly got adapted, quickly got implemented, because it provided that missing link, the glue to create the middleware. So distributed application advantages, okay, scalability, sure, server replication, thin, heterogeneous clients, reusability, partition functionality, easily updating for either clients or server. Yeah, okay, those are some good selling points. Competing technologies for distributed objects. This is where we start looking at it. So open standards are based solutions. So open standard based solutions. All of these guys fall into the same category. However, they all do different things. Java, does a very similar kind of middleware thing with the JVM on a standalone computer. CORBA does everything Java, EE does. Enterprise Java Beans does everything. There's overlap. RMI, in fact, there's overlap between the Enterprise Beans servlet concept and RMI. You can use them all together. So this entire list here, JNI, JDBC, servlets, Java Security, all fall into the same category. They're all solutions that provide different features. All of them are pretty much at this point providing the same features. It's kind of like if you think about it, all desktop computers, aren't they all doing the same thing these days anyway? It's the same parallel. All of them have mail clients and web browsers, and they all support some version of Microsoft Office and stuff. And then we have the all Microsoft solution. Opposite side of the fence. Not compatible, doesn't do the same thing, and doesn't all work together. So CORBA fits in this category with Java, which is why I'm mentioning it in this class. If you were to take a .NET course, if you were to look at C++, C#, anything on the .NET platform, you're not looking at CORBA. you're not looking at Java either. You're looking at solutions that are solved by .NET, which is the equivalent actually in terms of its functionality, but totally different breed of middleware. .NET is middleware as well. Does the same thing. .NET actually provides nice security, transaction management, distributed objects, you name it, it does the same thing. It's just on a different server for a different platform. Other proprietary solutions, message-oriented middlewares, transaction processing monitors, and things of that nature. It's kind of ironic. We're actually going .NET at ITU. All of the enrollment systems and everything is all switching over to this brand new system, which is kind of interesting. But if you think about it, though, we're a university, and the .NET platform actually in the application development is a lot, well, it's more expensive because it's not open connectivity. It's not free. But It provides a lot more features for security, and like banking systems like it, universities like it, for financial systems and stuff. Because there's a lot more features to support transactions, security, a little bit more reliability and stuff like that built into it. So it depends on the nature of the application as to what you're going to select. Transaction processing monitors or web front ends quickly extend existing applications for access from the web. Client context maintained by the server. I always think of these transaction monitors. All right, so a deviant from that, but slightly some crossover in concept is the shopping cart. You know, it's running on the server. It's keeping track of client information normally, hopefully. It's providing that transaction support between both the client and the server, synchronizing the sale. So, and what's happened actually lately is everything has moved to the server. Nothing's on the client anymore. So once you've hit send, doing, gone off the client, and then you end up getting a confirmation email, or you get a web page that comes back at you and when everything's all done and ready to go. And then you see that separation, as a user, you see that separation. You know, oh, no longer on my client anymore, because everything disappears from you, usually. You know, your screen goes blank for a few minutes. No, it doesn't. Yeah, I don't know. You know, it depends on how you design the application, but I can always see when I'm using an application, I always try to guess, you know, what are they using here? And most of it's server-based. In the old days, it used to be client-based, which was, you know, written in Java, written in JavaScript, written in applets and stuff like that. I'm like, whoa, that's not very secure if you think about it, because, you know, whatever's on the client is freely distributed. So, okay, so here's an example. BEA Jolt is a technology for transaction monitoring for web front ends. We can limit the single process to a single machine, not object-oriented, truly distributed. Jolt provides, server provides, consumes an additional resource as well. Clients must be either pre-installed or downloadable. So the BEA Jolt has some limitations to it, and what we're doing here is kind of going over some of the non-CORBA sort of technologies just to compare it. It hasn't turned into the sales pitch yet, so I'll continue going. But COM, DCOM, COM Plus, compare that technology. Well, it's rich, well-known platform, object-oriented, web client access via ActiveX controls, still being used, very common, or active server pages, HTTP requests, and IIS, and distributed as long as it's Windows, it's distributable. So it works on well, COM, DCOM works on Windows platforms. NT only, we don't have very much of it out here anymore. We can possibly say it works. It is actually supported on current Microsoft servers, but it was designed initially for NT. Firewall issues, limited flexibility, limited security. So CORBA versus ad-hoc network apps. Ad-hoc. Java EE could be considered ad hoc in some ways, only because if you've seen, it's all broken out into different little pieces. You don't have to run RMI, you don't have to run Java Enterprise Beans, you don't have to run JSP or servlets, you don't have to have a web container, you don't have to use containers at all, you don't have to have a web server, application server. You can just configure the whole thing you want. That's what ad hoc, if you're not familiar with the word. It's ad hoc, it's hodgepodge thrown together. So, not really thrown together though, it's just piecemealed is another word for it, ad hoc. So compare Java as all in one unit versus separate parts and pieces and components that you can put together. So that's what CORBA is providing over Enterprise Java Beans in some ways. It's providing you a solid, we just install CORBA. Hello, it's a little easier. So technical considerations, CORBA Java Enterprise Beans implementations have integrations with object databases, transaction services, security services, directory services. CORBA implementations automatically optimize transport and marshalling strategies. Didn't really talk about marshalling, but it usually comes up with the RMI. And there's a little bit about marshalling. Not really a topic I discussed heavily in this course, but Let's see, CORBA implementations automatically provide threading models and things. So it's going to give you better support as a foundation technology. In terms of business considerations, standards are based. Multiple competing interoperability implementations, buy versus build trade-offs, resource availability, software engineers, tools. CORBA is kind of an interesting breed of people that go into that. It's usually senior level, mid-career executive, technical people. I have a really strong CORBA because they've been working with CORBA. Fresh out of school, probably they're not going to expect. No one's going to expect you to know anything about CORBA. It's kind of an old technology, so. And who knows? It's still around now. But COBOL, it's just like when you graduate from college. You're not going to say, do you know COBOL? What's COBOL? Do you know Java? Java you probably should know, but COBOL, nah. Fortran, nah. Smalltalk, no. But those languages are still around too, and they're still being used. So now they're gonna ask you .NET. And then if you say no to .NET, oh, Java. So then I know what side of the fence you sit on. So, all right, back to the lecture. The Object Management Group, if you have never heard of that, OMG, it's been around for centuries as well. Over 855 member companies formed, developed distributed object standards. This is back when we were trying to put standards on stuff. In fact, distributed computing in general, this is probably the only, don't quote me on this, but this is one of probably a handful of standardizing companies, or standardizing groups, I should say. Just like Java is not standard either. In fact, if you think about it, TCP is not standard, even as a transport protocol. IP is standard, but TCP isn't. So UDP is not standard either. So some really weird technologies are standardized, some aren't. Enterprise computing, distributed objects, not standardized for the most part. OMG was an attempt to standardize it. Accepted proposals for various different standards, put forth defined communication infrastructures, standard interfaces between objects, object services. CORBA follows this. So developed in the spec for Common Object Request Broker Architecture, which is what CORBA actually stands for. So Common Object Request Broker Architecture. Doesn't that sound like remote object? Yeah, doesn't it? Remote object invocation, Java Bean, servlet, server. Yeah, it's pretty much remote / object-oriented distributed interfaces. So the goals and the characteristics. No need to predetermine the programming language. So that's pretty good. In fact, let me go back one more comment on Object Management Group. This was an attempt to standardize. And as I mentioned before, this is a standardized, it's still around actually. However, not everybody follows it because you don't have to. If everybody followed it, we wouldn't have two sides of the fence. We wouldn't have .NET and Microsoft, and we would not have Sun and Oracle and Java on the other side. It would be all together. Everybody would be compatible with everybody else, which was what the goal of the OMG was to make it compatible. Okay, so what did CORBA do in terms of its design, goals, and characteristics? Well, you just said, well, let's just install the platform, and then we pick out the programming language. Now you don't do that. You can't do that. If you're going .NET, you cannot program in Java. So they made it so, part of the standard goal was to make it programming language independent. So you install it, hardware platform itself, the operating system itself, no need to predetermine anything. You just built the application to build the application. Then you decided on all of the details in terms of the implementation. Made it more flexible, made it extendable, made it easy. Specific object request brokers, no degree of object distribution, nothing needed to be known. It was an open architecture, language neutral, I shouldn't say is a natural language neutral interface definition language, which is what IDL stands for. Language neutral, interface definition language, language platform and location transparent, which means we don't have to worry about tiering. So you just move things anywhere you wanted to. Location didn't matter, which just means it includes JNDI technologies, which it does. So objects could act as clients, servers, or both, and the object request broker, or the ORB, mediates the interaction between clients and objects. And that's pretty much what we're looking at in terms of having a clear solution, which is why, okay, so this slide here is why people go for CORBA. It's flexible, extendable, open, standard-ish-ized. So, and if you're a big company and you don't know, and you got to mix and match parts and pieces from a lot of different components, some old, some new, and you have to support legacy systems, CORBA. If you're brand new, you're Acme Inc. software development company, and you're putting together a distributed server, and you don't have to support anything old because nothing's past yesterday, and you're buying brand new equipment and you're putting everything in, you'll probably go the Java EE route. That's what I'm thinking. Or you'll probably go something a little bit more, or .NET actually. If you're thinking you're going to only support ASP, or you're only going to support Windows applications, and you're going to be running on Windows clients, then you're going to do the .NET. So depends on your goal. But CORBA does still have a place in the market. So the IIOP is the Internet Inter-Orb Protocol. So unfortunately what you get with CORBA is a bunch of acronyms for different technologies. So Internet Inter-Orb Protocol, communication or remote invocation, equivalent to sort of similar to RMI. But it's a crossover. It doesn't include everything RMI. It's it's terminology used to describe the orb interaction. Specified by the OMG, the standard communication protocol between the orbs. Resident on top of TCP/IP, runs on top of, actually everything runs on top of TCP/IP these days. The entire internet runs on TCP/IP. So if you're going to support the internet, you're going to run on top of TCP/IP. So that's a given. Developers don't need to learn IIOP. The orb handles this for them. So it's hidden protocol that's used inside. Specific common format, the orb references known as the inter-object reference, IOR, inter-object references. Messages exchanged between clients and objects. Key definitions. Here we have two, the ORB and the BOA. The ORB is what we've been introduced to so far, which is the object request broker, ORBs. They transport a client request to a remote object and returns the result. I'm not going to go through all the little implementation details, but I'm just giving you the terminology, just in case you read about this somewhere. Object adapter, OA, abstract specification, part of the server-side library, interfaces with the ORB and the server processes. Basic object adapter, that's where the BOA comes into place, is a concrete specification, first defined OA for use with CORBA and compliant ORBs. Leaves many features unsupported, requiring proprietary extensions. Well, if it's unsupported, it means you have to fill it in kind of ad hoc nature. CORBA can actually be working in an ad hoc environment as well. It's not specifically, just CORBA. I mean, you can actually work it with Java as well. It's an object reference. It's distributed computing equivalent to a pointer. So we have, remember C++ and pointers and memory. Well, that's an object reference. It speeds up the communication because we don't actually have to talk to the object. We just have to know where it's located, and we can read and write to it. And we can use the pointer instead of the instance of the object actually as well. And here's where I'm going to start picking up the pace a little bit, because you don't have to really know very much about CORBA for this class, but it's supposed to be a brief introduction to it. CORBA object characteristics. CORBA objects have identity. They have references, can be persistent, or they can be state session oriented. They can go away. And they can be relocated and moved around in runtime. So can Java objects. So server characteristics. They say the server, we usually mean the process, server process, not server machine. One or more CORBA server processes can be running on the machine. So we can run multiple instances, processes of CORBA for different applications or for different things, or we can run it all together. Each CORBA server process may contain one or more CORBA object instances. So you install a server and you install CORBA, and you have different instances of it working for different applications or different purposes. So what does that remind you of? Servlets. So you can put a servlet on that same machine along with your CORBA, or your remote object broker. So, well, actually, really, you don't ever heard the word CORBA. You usually hear orbs used a lot to define CORBA, because that's what you're doing. You're using the object request broker to serve up objects in a distributed environment. So you can build orb interfaces into applications to make them distributed. So, how are you going to do that? Well, maybe a peer-to-peer program or something is going to use that. It's going to bring people together that are located all over the place and make it seem like they're all working together on one place, one time. Server process does not have to be heavyweight. Java applets can be CORBA server. It can actually be as small as an applet. Interfaces and implementations, same concept exists. The IDL interface is this is supposed to be sort of a wrapper around the object. Looks like Saturn, this little ring around the object. But it's not really a ring. It's supposed to actually be enclosing the entire object. It's the interface to the object, hides the object. Everything I said about interfaces for Java, same for CORBA. So works the same way. One interface, multiple implementations possible. One implementation may be supported by multiple different interfaces. What are the implementations? Those are the objects, the pieces. We never talk about beans. We only talk about objects, but everything's an object. So beans and objects are pretty much the same thing in CORBA. So location transparency, we don't know if machine X or machine Y, but we have process A, B, and C running. And they're all running together as if they were all on the same machine, but process C is over here on machine Y. So stubs and skeletons, same concept as before. This really reminds me of RMI though, because this guy down here, the orb, he's the RMI registry. Ask the registry something, and then this guy over here is the stub. He's the client program. He calls over, asks the registry something, and it serves up the object through the skeleton, which is the interface. So this very similar, yet implemented differently, and not to be confused as the same. It's different. It's different because it has different features and different components, different security, different mechanisms, and a different implementation completely. And it's not written in Java either. So basic object adapters, orb operations and things are part of the responsibilities. It's a multi-threaded server, IDL interface that works. Dynamic invocation interfaces as well, where we can dynamically invoke instances of objects and manage object lifecycles through this broker, object request broker. Think of the broker as the middleman, if you want to think of it that way. So, and an interface repository, so the broker actually houses the interfaces. They can go through them. So this is where it turns into a sales pitch. Why IDL? I'm going to skip through this. All right, so simple data types. Yeah, there we go. So you can download this. I believe it's lecture number 7. It is kind of interesting, though, to see CORBA, these examples here. Written in Java, we can implement, and here's a Java class, right? Here's a Java client, and now we have import org.omg.corba. So we're using the object instances right inside of Java. So if you know Java, you can program with CORBA. So unless you run into a company that is using it, you're probably not going to get any experience with it. And there's people that can go your entire programming career and never touch CORBA because not everybody uses it. And it depends on the company you're working for, whether you're going to see it. And nobody really expects for you to have very much experience with it either, which is nice. Because it's kind of, I mean, if it were .NET and you were applying for .NET job, you're going to have experience in it. They're expecting that. Or Java, yeah. But something that is off the beaten path, which has been around for a long time, it's kind of like Smalltalk. Nobody expects you to have any experience in Smalltalk either. But that's used a lot. Or CORBA used a lot. So, but the technologies themselves overlap. So so that was the Java example. There's a Java server and client object, and we're importing the CORBA from OMG, and we're making instances of that object. And here's one here, orb. We're making an instance of orb, running the init instead of running a constructor. We're actually running a method to initialize. And here's a C++ client. So if you like C++, as I mentioned before, you can use CORBA with C++, with Java, Smalltalk, anything you want. Somebody asked me a long time ago, what is Smalltalk? It's a programming language. One of the first programming. It came before Java. Java obviously took it over completely, but it was invented as a language for printers. And the funny thing is so was Java. Do you know Xerox, Park Place Xerox, Digitalk? Actually, that was one of my first jobs, actually, right out of school. Did support for Smalltalk, so I'm very familiar. I used to be very familiar with it. It's been years since I've programmed in it. But then I remember, and now I'm dating myself, I remember when we were testing the first version of Java, we went, uh-oh, we're going to lose our jobs soon. Java's going to take over the world. And it did. So, but Java actually has a little bit of Smalltalk in it. It's very similar, and it's totally built on model view controller. So it has a little C++, Objective-C kind of thought in it. It's a kind of a hybrid. Java is really, it started out as a hybrid. But it's interesting. It's interesting to see how the language has evolved. But there's still companies that are using it because, you know, printers, they'll have operating systems on them. So they used to be all Smalltalk from Xerox. You made printers, photocopiers. Now they're most of them are Java-based. So, but you know, the first Java, the JVM, the first JVM that was invented was for a printer. Actually, it was a printing language. So, who knew it would be working on computers or on distributed networks in the future? But I'm waiting for Java to go away. I don't think it's ever going to go away. But I'm waiting for the next level of language to come out. Who knows? It'll program itself. You just talk to it. Maybe, I don't know. All right, here's your C++ client, your C++ server. You know, it looks the same. Essentially, you're importing the classes instead of, including the classes instead of importing them using different syntax, but essentially accomplishing the same thing, making instances of orbs, objects that are acting as a brokerage between the different objects. Services has defined a common object service. The OMG owns the set of common object services, frequently used by components needing to build robust applications, typically supplied by vendors. OMG defines the interfaces with services to ensure interoperability. So it's just, you can't really give CORBA the credit. It's OMG that gets the credit for the interoperability between all of the different languages and platforms. All right, so I'm going to breeze through this because we've already seen this real recently. We just went through that entire lecture that I did for the last 3 weeks on Java naming, Java beans, Java components. All right, this is the same thing. Naming, events, notifications, transactions, same thing that we got with Java is supported with CORBA. Here's the big picture. I kind of like this picture. It looks kind of nice. We got the Java-enabled web browser over here. We got the HTML page. We got the Java applet that's going to the HTTP web server, a web proxy. And then here we're using, here's where the CORBA fits in. IIOP, Internet Interoperable Protocol that's going back and forth. That this is the middleware that CORBA is doing with the Java, with HTTP. You know, so it fits right in. Relational database down here, the distributed objects over here, the naming service over here, and this is our component that we're mixing in, blending in CORBA with. So, future CORBA, this is outdated. Final adoption, well, CORBA 3. I don't know what we're up to right now. I'm not really a huge fan of CORBA, actually, just because I haven't spent very much time around it. I haven't had very much exposure to it. Vendors themselves, you can actually, Borland's no longer around. The second one's no longer around. The third one, I suspect that perhaps this last one is the only one, Object Space, which I believe is now Object Share, is still in business, but not too many of them. Real world implementations, well, commercial products, Oracle 8. Starting with Oracle 8, it started out using CORBA as a foundation. In fact, Oracle supports web objects. But future versions of Oracle are going to be Java. Java-supported distributed objects and web services because of who they own, you know. as soon as that merger happened. Oracle's heading off in a different direction. Silverstream Application Services no longer in business. BEA is still around. WebLogic, Vitra, I've never even heard of this one. Evergreen, e-commerce, Get Active Access Servers. All right, so whether or not they're around or not, this is just some examples of people who have used it in the past. Cisco Internet Networking Product Center used to use it. I'm not sure if they're using it now. The slide set's kind of dated. It's about 10 years old, actually. So, and here's some resources. OMG is still around. You can still go to omd.org, and you can still read about that. In fact, these guys are still running pretty strong. Washington University, don't even know if that works anymore, but free CORBA page, you can go out, actually just search on CORBA, and you'll see tons of information if you're interested. The news groups, does anyone actually use news groups anymore? I don't know. No, news groups providers? No. Old days, news groups were very popular. These books are no longer in, actually this one is, Client-Server Programming with Java and CORBA is still in print, actually. Programming, this is, whether or not this one is, I would suspect it might be, but I don't know. But the first one I have seen around, oh, this passed the second edition now. It's probably in the 9th or 10th edition at this point, so. That was everything you ever wanted to know about CORBA. Actually, it was a brief introduction to CORBA, because this is a Java class. I didn't spend too much time with it. However, it's nice to know what you're competing against, or what you're using, because some Java people will run into CORBA, will use CORBA, or object request brokers of other vendors as well. So next week, I have a conference that I have to go to. Actually, here, let me end the video so I can do the administrative stuff.